Here's our first lesson for our strength of materials. Introduction. Strength of materials, also called mechanics of materials, deals with the behavior of solid objects subject to stresses and strains. The complete theory began with the consideration of the behavior of one and two-dimensional members of structures whose states of stress can be approximated as two-dimensional, and was then generalized to three dimensions to develop a more complete theory of the elastic and plastic behavior of materials. So we will be dealing with stresses and strains in strength of materials based on two-dimensional or even three-dimensional. Okay, for the first stress, which is a normal stress, prior to that, we define what is stress. Stress is defined as the strength of material per unit area or unit strength. It is the force of a member divided by area, which carries the force, formally expressed in PSI or in English system, which means pounds per square inch. Now, in metric system, it is Newton per millimeter square or MPa, which is megapascal. And the formula for normal stress, sigma, is equivalent to P over A, where P is the applied normal load in Newton and A is the area in millimeter square or the cross-section area of the material. The maximum stress in tension or compression occurs over a section that is normal to the load. Normal stress is either tensile stress or compressive stress. Members subject to pure tension or tensile force is under tensile stress, while compression members subject to compressive force are under compressive stress. So in this diagram, bar in tension of the bar is elongated, while in bar in compression, it compresses, which means the length of the bar is shortened. And compressive force will tend to shorten the member, while tension force, on the other hand, will tend to lengthen the member. So example, a hollow steel tube with an inside diameter of 100 mm must carry a tensile load of 400 kN. Determine the outside diameter of the tube if the stress is limited to 120 meganewton per meter square. So we have a hollow steel tube and the diameter, which is the inside diameter, is equivalent to 100 millimeter. And we're going to find out or determine the outside diameter of the steel tube with a stress which is limited to 120 meganewton per meter square. So the formula for our normal stress, sigma, is equivalent to P over A, where P is equivalent to 400 kilonewton, and the stress, which is the sigma, which is equivalent to 100 meganewton per meter squared, or this is equivalent to 100 megapascal, wherein Newton per meter squared is equivalent to Pascal. Next, we will find the value for A, which is the cross-sectional area of the steel tube. Then, based on the equation 1, stress, which is 100 megapascal, is equivalent to P, which is equivalent to 400 kilonewton, and divide by the area. Therefore, we need to convert the units. So 120, which is megapascal, or mega means 10 times exponent 6, and pascal, which is Newton per meter squared, and it is equivalent to 400 kilonewton means 400,000 or times 10 to the power 3, and it is in Newton, and divided by the area. Therefore, we will get the area, which is 400 times 10 to the power 3 divided by 120 times 10 to the power 6, and it is in Newton per meter squared, and this is in Newton, or equivalent to, let's check. So 400,000 divided by 100 million, so 120,000 million, and it's equivalent to 0.003. So this is 0.0033, and it is in meter square. However, the given diameter inside diameter is in millimeter, so therefore we convert meter to the millimeter. So 0.003, okay, converted. So 0.0033 in meter squared, which means 1000 millimeter is equivalent to 1 meter. So 1000 millimeter divided by 1 meter and square, or if we multiply 1000 squared by 0.0033, which means 1000, 1, 2, 3, or 1 million, which is equivalent to 3000, or this is equivalent to 3333.33 in millimeter square. Or the area is equal to 3333.33 in millimeter squared. However, how do we get the cross-sectional area of a hollow steel tube? So the area diameter, okay, the area outside diameter minus the area inside diameter is the area of the cross-section area of the steel tube, which means this is the shaded area is the cross-sectional area of a steel tube that is a hollow. Then we have the what is the area of a circle? So the area of a circle for outside diameter is equivalent to, based on diameter, it is pi over 4 d outside squared minus the area inside diameter, it is pi over 4 and d inside diameter squared, and it is equivalent to area. Then we substitute the value of diameter inside, which is 100 millimeters. So the area is 3300.33 is equivalent to pi over 4. Diameter outside is the unknown squared minus pi over 4, and diameter inside is 100 millimeter squared. Then we separate pi over 4, which means pi over 4 open close diameter d outside squared minus 100 squared, and this is 3333.33, and then we multiply, we will have d outside diameter minus 100 times 100, which is 100 or 10,000, and it's equivalent to 3333.33 all over pi times 4, and we will be having a value of times 4 divided by 3.1416, which is equivalent to pi, and this is equivalent to 4244.12 and the outside diameter squared transpose negative 10,000 to another side, which is positive 10,000, and the outside squared is equivalent to 4,000 plus 244.12 plus 10,000, which is my equivalent to 14,244.12, and diameter outside we will be having a square root 14,244.12 is equivalent to 1,000 or 119.35 millimeter. Yes, and that's correct.